We'll start with model 2 now. Okay. Write the headline, model 2. Model 2. That is laws of prestresses. Okay. Losses in prestresses. Losses in prestresses. Okay. Now, so in the model 1, what we learned is all the basic things about the pre-stressing system. How, what are the different types of pre-stressing systems? Okay, and difference between the pre-tensioning and post-tensioning. Difference between PAC and RCC. Okay, and yes, who's that?
ನಾವೇ ಕೊಡ್ತಾನೆ.
Umesh, mute the audio. Okay. So all basic things we have learned, and we have also learned the analysis of stresses for a pre-stressed beam. Correct. So when a pre-stress is induced in a member, okay, in a pre-stress or pre-stressing force is induced in a member, there is few or there are some losses that will occur in the pre-stress. Okay, there are some losses caused for the pre-stress or pre-stressing force. Okay, and those losses are mainly divided into two category. Okay, two category, that is pre-stress losses. Pre-stress losses is divided into mainly divided into two category. One is immediate losses. Immediate losses. Okay, what is the meaning of immediate losses? The loss of pre-stress will take place immediately after inducing the pre-stresses into the member. Okay, at the initial stage itself this loss will occur. That is called as initial loss. And second category is time dependent loss. Time dependent loss. Okay, so time dependent means these losses will take place after certain time. Okay, after certain duration, or after some uh, time after the pre-stressing force is been induced into the concrete. Okay, that is why they are called as time dependent losses. Okay, and in immediate losses there are three different types of loss will take place. Okay, one is loss of pre-stress due to elastic shortening. Elastic shortening. So many times this theory question is asked in your external examination. Okay, to describe about different types of losses. Please understand. And the second one is loss due to friction. Loss due to friction and loss due to anchorage slip. anchorage, slip. Okay, these are the immediate losses that will take place in a pre-stressed concrete member. Okay, immediate losses that will take place in a pre-stressed concrete member. That is loss due to elastic shortening of the member or elastic shortening of the concrete, loss due to friction, loss due to anchorage slip. And time dependent losses are loss due to creep, then loss due to shrinkage, and one more loss is due to relaxation of stress sensitive. Loss due to relaxation. Okay, these are all time dependent losses. Means these losses will take place after certain duration, after certain period. Okay, of the pre-stressed concrete member. Okay. So total 6 types of losses. In that, 3 losses are immediate losses. Means these losses will take place immediately after the pre-stress being induced into the concrete, and 3 more stresses are time dependent. Okay, these will take place after certain time. Okay, after the pre-stress being induced into the concrete. Okay, now let us discuss one by one. First one is loss due to elastic shortening. Loss of pre-stress due to elastic shortening. Okay, loss of pre-stress due to elastic shortening. Okay, now in case of pre-tension member, no, in case of pre-tension member, what happens is so assume that this is the tendon. Which is carrying a pre-stressing force of P. Okay. In case of pre-tension member, no, when the pre-stresses are suddenly induced into the concrete, okay, induced into the concrete, okay, when pre-stresses are suddenly transferred to the concrete, okay, for pre-tensioning member, what happens is there will be shortening of the length of the concrete member. Okay, there will be shortening of the length of the concrete. Okay, this shortening of the length of the concrete will in turn reduce the length of the pre-stressing wire or length of the tendon. This will cause reduction in the pre-stressing force. Okay, this reduction in the pre-stressing force will cause reduction in the pre-stresses. Okay, reduction in the pre-stresses means loss in the pre-stresses. Okay, this is how the loss due to elastic shortening of the concrete takes place. Okay, I hope you understood. When the tendons are suddenly cut, okay, after the concrete gets hardened for a long period of time, then what happens? Suddenly the pre-stresses will be transferred into the concrete. During the process of transferring of the pre-stresses, there will be slight, not to the maximum extent, there will be slight reduction in the dimension or length of the concrete member, which will in turn reduce the length of the tendon. So when the length of the tendon decreases, the pre-stress, the magnitude of the pre-stressing force decreases. When the magnitude of the pre-stressing force decreases, there will be reduction in the pre-stresses, okay, due to the pre-stressing force. Okay, this is how the loss of pre-stress will take place due to elastic shortening. Okay, now how to measure this elastic shortening? That's the question, correct? How to measure this elastic shortening? This elastic shortening, loss due to elastic shortening mainly depends on uh, the material property, correct? the material property and stress at the level of the concrete, the stress in the concrete at the level of steel. Okay. Therefore, the loss due to, you need to remember all these formulae required for solving the problems. Okay. Loss of pre-stress due to elastic shortening is calculated as, so here you can see this loss due to elastic shortening mainly depends on material property. Material property means it may be the property of the concrete or it may be the property of the tendon. Okay, so on both material properties, this loss due to elastic shortening depends. Okay, means it mainly depends on the modular ratio M into stress in concrete at the level of steel. Okay, what is modular ratio? Modular ratio is the ratio of Young's modulus of steel to that of Young's modulus of concrete. Okay, nothing but modular ratio. Okay, so this loss due to elastic shortening mainly depends on material property. That is why material property is nothing but the ratio of the Young's modulus of steel to that of concrete. Nothing but modular ratio. Modular ratio multiplied by stress at the level of steel, stress in the concrete at the level of steel, FC. Okay, so if you multiply both values, then you will get loss of pre-stress due to elastic shortening. Okay, then Young's modulus of steel, it is a known value. It is 2 or 2.1 into, or how much? 10 raised to 5 Newton per mm square. So sometimes it will be given, sometimes it will not be given. If it is not given, you need to remember this value, Young's modulus of steel. I think you are familiar with this constant. That is 2.1 into 10 power 5 Newton per mm square. The Young's modulus of concrete, sometimes it will be given, sometimes the compressive strength of the concrete will be given. Okay, characteristic strength of the concrete will be given. If the characteristic strength of the concrete is given, you can calculate the Young's modulus of the concrete by using the formula, that is 5700 root of FCK. Okay, utilizing this formula, you can calculate Young's modulus of the concrete. If it is directly given, so you can directly use the given value. Otherwise, you need to calculate. Okay, by using this formula. Then FC. What is FC? Stress in the concrete at the level of steel. Okay, FC is stress in concrete at the level of steel. Level of steel is equal to, it is calculated as P by A plus PE by I into E minus M by I into E. Okay. Instead of writing PE square, what I have written is PE into E. Okay. The purpose of writing this formula in this way, I will tell you while solving one of the problem. Okay. In future classes. Therefore, this FC, stress in concrete at the level of steel, is calculated by using FC is equal to P by A plus PE by I into E minus M by I into E. Using this formula, we will calculate stress in the concrete at the level of the steel. Knowing modular ratio and FC, you can calculate loss of pre-stress due to elastic shortening. Okay. Now, this calculation holds good for the pre-tensioned concrete beam. In post-tension concrete beam, in post-tensioned concrete beam, say in case of post-tension concrete beam, what is the process involved in post-tensioning? What is the process involved in post-tensioning? Initially, the concrete will be poured into the mold and it is allowed to cure. Okay. After that, the post the concrete is placed, then the tensioning of the wire will be done and pressures are induced into the concrete. That is what the process involved in the post tensioned concrete beam or post tensioning. Okay. So in that process, if okay, if the cables are stretched simultaneously, if the cables are stretched simultaneously, okay, in case of post tensioned concrete beam, okay, if the cables are stretched simultaneously, there is no loss since the applied stress is recorded after the elastic shortening has completely occurred. Okay, understanding? Here, in case of post tensioning, this tensioning of the wire will be done after the placing of the concrete and its hardening. Correct? Huh? So if these wires are stretched simultaneously and released, okay, and released, whatever the stress induced in the member, no, the stress is recorded, the initial pre-stress, okay, initial pre-stress P is recorded after the loss due to elastic shortening only. Already it is considered at the beginning stage only. Okay, considering that elastic loss due to elastic shortening, this initial pre-stress will be defined in case of post-tension concrete beam. Okay, therefore, if the wires are stretched simultaneously, no need to calculate, no need to calculate loss due to elastic shortening for post-tension concrete beam. For pre-tension concrete beam, you need to calculate compulsorily. Okay. For the same post-tension concrete beam, okay, for the same post-tension concrete beam, if the wires are stretched one by one, if the wires are stretched one by one, okay, one by one, there is loss of pre-stress in tendon during subsequent stressing of tendons. Okay, there is loss in each tendon during subsequent stretching of the tendons. In this way, in this case, you need to calculate loss of pre-stress due to elastic shortening. Okay, in the problem, it will be clearly said. Okay, whether the cables are stretched simultaneously or one by one. If he says cables are stretched simultaneously, no need to calculate loss due to elastic shortening. If he says cables are stretched one by one, then you need to calculate. Okay, that I will be that calculation part I'll be explaining in detail while solving the problems. Okay, so understand this much. If the cables are stretched simultaneously, there won't be any loss due to elastic shortening. If the cables are stretched one by one for post-tension concrete beam, there will be loss. Okay, then using the same formula. Okay, using the same formula M and TFC, you will calculate the loss in the pre-tension post-tension concrete beam. Okay, for pre-tension concrete beam, compulsorily you need to calculate loss due to elastic shortening. Okay, so I hope this is clear for everyone. If you have any doubts, you can ask. Thank you. Now we will discuss the second immediate loss, that is loss due to friction. Second one, loss due to friction. Okay, loss due to friction. Okay, this is also one of the immediate loss that will take place in the pre-stressed concrete beam. Okay, and coming to the loss due to friction for pre-tensioned concrete beam, we will not calculate loss due to friction because in case of pre-tension concrete beam, what is the process of pre-tensioning? You just remember the process of pre-tensioning in the concrete. See here, there in case of pre-tensioned concrete beam, initially the tendons will be stretched. After that, concrete will be poured. Then after the concrete achieves the sufficient strength, the tendons being cut on both the ends so that there will be transfer of pre-stresses in the concrete. Okay. How that transfer of pre-stresses will take place in case of pre-tension concrete beam? So this is the concrete. Okay. So what happens? Initially the tendons will be stretched. After that concrete will be poured. Then it is allowed to harden. Then tendons are cut at the ends so that stresses will be transferred. Okay, stresses will be transferred into the concrete. So due to the friction between the surface of the tendon or pre-stressing wire and the concrete, only the pre-tensioning will take place in the member. Okay. So therefore, here we need not to calculate loss of stresses due to friction in case of pre-tension concrete beam. Only we need to calculate loss of pre-stress due to friction for only post-tensioned concrete beam. Post-tensioned concrete beam. Here we need to calculate the loss due to friction. Okay. So in case of post-tension concrete beam, what happens? There will be ducts provided. Correct? There will be ducts provided in the member. Okay. Initially, they will place the concrete. After that, we will stretch the cable which are taken through the ducts. Okay, which are taken through the ducts. Okay. Sometimes what happens? If the cable profile is having a parabolic shape, okay, then what we will do? We will take parabolic duct only, parabolic shaped duct only. Okay, we'll take parabolic shaped duct only. Okay, so in this case, sometimes we'll also fill the mortar inside the ducts. Okay, so in this case, due to the different profile of the cable, okay, there and due to the friction between the surface of the duct to that of surface of the tendon, there will be losses in the pre-stress. There will be losses in the pre-stress. Okay, and there is one more effect called as oval effect. Oval effect. Okay. See, theoretically, we can define any kind of profile for this tendon. Okay. In the load balancing concept, what we'll do, we'll provide the cable profile by referring the bending moment diagram. Assume that in case of post tension concrete beam, cable profile is some like this. Okay. If cable profile is like this, while doing actual execution in the site, okay, while doing actual execution in the site, there will be some misalignment in this cable profile. Correct? There will be some misalignment in the cable profile. Because of this misalignment, okay, in the cable, there will be losses in the pre-stresses. Okay. So this is called as oval effect. So it mainly depends on the loss of pre-stress due to the friction mainly depends on the cable profile and the oval effect. Okay, oval effect. And let us see how to calculate this loss of pre-stress due to the friction. How to calculate loss of pre-stress due to the friction? It is calculated as loss is equal to loss of pre-stress due to friction is calculated as P naught into mu alpha plus Kx. Using this formula, we will calculate loss of pre-stress due to friction, where P naught is initial pre-stress, okay, and Mu is what? What is mu? It is coefficient of friction. Okay, it is coefficient of friction. Okay, then this alpha is called as cumulative angle. Okay, this is called as cumulative angle. Okay, this alpha value mainly depends on the cable profile, whether the cable profile is parabolic, straight, or linear cable. Okay, and type of the stretching of the cable. If the cable is stretched at one end, there is some different calculation for this alpha. If the cable is stretched from both ends, there is some different formula to calculate this alpha. So anyway, I'll be explaining in detail while solving the problems. Okay, and K is called as wave effect. Wave effect, or as I told, wobble effect, or wobble constant. Wobble constant or wobble coefficient. Okay, and you need to remember this formula, and there is one code book which is described in your syllabus. Let me show that code book. Code book. So IS 1343 1980 code book. Okay. So in this code book, in page number 33, I think. Yes. Here we have one formula. Okay. That formula is for calculating pre-stress at a section. Pre-stress at a section. Okay. If you can just write this formula, whatever I written just before, that is P naught into mu alpha plus Kx. Okay. P naught into mu alpha plus Ks formula, just this formula. This e power you can remove. Okay, you can remove this e power. Only it is P naught into mu alpha plus Kx. See, that for this formula is obtained after simplification of this equation. Okay, after simplification of this equation only. Okay, therefore, if you so in the code book, this formula is available. Okay, slight modification. After doing slight modification, you can write the actual formula for calculating the loss of prestresses. Okay, and of course, this formula is simplified version of this formula. Okay, the detailed calculation I have given in the notes. I will be sharing that. You will refer through it. Okay, then one more thing. This EC is equal to 5700 root of FCK, I told no formula. This formula is given in this code book only. I think in page number 16 it is given. Yeah, here it is given. Okay. So you can pick from this code book. Okay, this code book will be allowed for your examination. Okay, got it? Now, loss due to friction is over. Loss due to friction is over. Then what is next type of loss? Loss due to anchorage slip. Third one, loss due to anchorage slip. Loss due to anchorage slip. Okay. Where we will get the anchoring of the tendon? In case of post tension concrete beam only, we will get anchors, correct? For post tensioned concrete beam, only we will get the anchors. Okay, only we will get the anchors like this. Okay, but for pre-tension concrete beam, there won't be any anchorages, correct? Directly there will be tendon, okay, and tendon is stretched and released at the ends, so that due to the friction between surface of the tendon and the concrete, the stresses will be induced, the pre-stressing force will be induced. This is for pre-tensioning concrete beam. So there won't be any loss due to anchorage slip for pre-tensioned member. Remember this. You need not to calculate loss due to anchorage slip for pre-tensioned concrete member, because there is no anchorages only. There is no anchorages only for pre-tensioned concrete beam. This will come into picture only for post-tensioned concrete beam. Okay. So in most of the post-tensioning systems, when the tendon force is transferred from the jack to the anchoring ends, the friction wedges slip over a small distance. Okay, when the pre-stressing force, okay, are transferred to this anchorages, no, transferred to this anchorages. Okay. So when the pre-stresses are transferred to the anchorages, so there will be slight movement of these anchorages. Okay, slight movement of these anchorages. Okay, means there is some slip that will take place. Okay, so due to that slip, there will be small shortening of the length of the tendon. Okay, therefore, there will be losses due to anchorage slip in the post-tensioned concrete beam. Okay. Now, how to calculate this loss of pre-stress due to anchorage slip? So, it is calculated as loss due to anchorage slip is calculated as delta by L, okay, into ES. Using this formula, we will calculate the loss of pre-stress due to anchorage slip, where delta is amount of slip that has taken place near the anchorages. Okay, delta is amount of slip, amount of slip that has taken place at the anchorages, and L is beam span or length of the beam, and ES is the Young's modulus of the tendon. Okay, using this formula, we will calculate loss due to anchorage slip. Okay. Now we have discussed all the immediate losses. Now we'll move on to the time dependent losses. The first one is loss due to creep. Correct? Loss due to creep. Fourth one, loss due to creep. Loss due to creep. Loss due to creep of concrete. Okay. What is creep? Already know you are familiar with creep and the shrinkage. Correct? You are already familiar with creep and the shrinkage. What is the meaning of creep? Loss of stress due to the sustained loading, continuously applied loading for the long duration. Okay, it's called as creep. Due to the sustained pre-stress over a long period of time, okay, there will be loss of pre-stresses. Okay, loss of pre-stresses. Okay, sustained loading for long period of time. Okay, loss of pre-stress due to sustained loading for long period of time is called as loss due to creep. Okay, and that mainly depends on the creep coefficient or ultimate creep strain. Okay, it is calculated in two ways by using creep coefficient. Okay, using creep coefficient, creep coefficient, we can calculate the loss of pre-stress due to creep. That is loss loss is calculated as pi into Fc into m. Okay, where pi is the creep coefficient. Okay, where pi is the creep coefficient. And Fc is same stress in the concrete at the level of steel, and m is modular ratio. Okay, next, second one. Sometimes he will give creep coefficient in the problem. Sometimes ultimate creep strain will be given. Ultimate creep strain will be given in the problem. Okay, and it is denoted as epsilon cs. Okay, it is denoted by epsilon cs. Using this ultimate creep strain, the loss is calculated as epsilon cs, okay, into fc into es. Using this formula, we will calculate ultimate loss due to creep in the pre-stress concrete member. Okay. So where epsilon cs is ultimate creep strain, fc is stress in the concrete at the level of steel, and es is Young's modulus of the steel. Okay. So this is how we will calculate loss due to creep. And moving on to the next type of loss, which is the next type of loss, it is loss due to shrinkage. Loss due to shrinkage. Loss due to shrinkage. What is the meaning of shrinkage? What is the meaning of shrinkage? Shrinkage is reduction in the volume of concrete, okay, over a period of time. Okay, why the reduction of the volume of the concrete will take place? In the actual volume of the concrete, there will be some reduction in the volume. Some reduction in the volume. Okay, why this reduction in the volume means if there is excess water added into the concrete, which is more than that is required for hydration process, then that excess water will get evaporated out from the concrete member, okay, leaving pores inside the concrete, which will in turn reduce the volume of the concrete. That is a process of volume reduction in the concrete, which is called as shrinkage. Okay, due to this shrinkage, reduction in the volume of the concrete, there will be reduction in the length of the tendon, which will reduce the magnitude of the pre-stress or pre-stressing force in the tendon, which will reduce loss of pre-stresses. Okay, which will reduce loss of pre-stresses. And loss due to shrinkage is calculated depending upon the type of member, whether it is a pre-tension member or post-tension member. Okay, the loss due to shrinkage is calculated as the product of shrinkage strain into Young's modulus of steel, ES, Newton per mm square. So by using this formula, we will calculate shrinkage strain. Loss due to shrinkage. Okay, and the value of this shrinkage strain depending upon whether the member is a pre-tensioned member or the post-tensioned member. Okay, if it is a pre-tensioned member, the shrinkage strain value is taken as 0.0003. Okay, it is taken as 0.0003. Sometimes it will be given. If it is not given, you need to remember. Okay, shrinkage strain in concrete is assumed as 0.003 for pre-tensioned member. Okay, and it is calculated by using the formula 0.0002 divided by log of base 10 into t plus 2 for post-tensioned member. Okay, and this formula is given in the code book. Okay, I think in Page number 16 only it is given. Yes, here it is given. Okay, both the values are given. You can take from this photo. Okay, where T is age of concrete at transfer in days. Okay, this age of concrete at transfer it will be mentioned in the problem. So we need to substitute the same value and get the shrinkage strain coefficient. For pre-tensioning, it is directly 0.3103. Okay, this is how we calculate loss due to shrinkage. Okay, now which is the next type of loss? Last one, stress loss of pre-stress due to relaxation of stress in steel. Last one, sixth one, loss due to relaxation of stress in steel. Loss due to relaxation of stress in steel. Okay. What is the meaning of relaxation of stress in steel? Relaxation of stress is nothing but reduction in stress with the time at a constant strain. Okay, if you take any elastic material, okay, if it is kept stretched for over a long period of time, it will lose its elastic property. It will lose its elasticity property. Correct? So in that way, there will be relaxation of stress in the steel. Okay. So there will be reduction in stress with the time at constant strain in the steel. Okay. So loss of pre-stress due to relaxation of stress in steel is calculated as loss is equal to percentage of initial pre-stress. Initial pre-stress. Okay. So this is a very easiest way to calculate the loss of stress due to relaxation of stress. It's a very simple calculation. The percentage of loss due to relaxation will be given in the problem. Initial pre-stress will also be given. Knowing the initial pre-stress and the percentage of loss due to relaxation, you can easily calculate the total loss due to relaxation of the stress in steel. Okay, so these are all the different types of losses that will take place in a pre-stressed concrete member. Okay, now what we'll do is we'll make a tabular column. Okay, type of loss. Okay, then pre-tensioning. Post-tensioning. So we'll list one by one. So first one is what? First one is loss of pre-stress due to elastic shortening. First one is elastic shortening. Loss of stress due to elastic shortening. Okay. Clearly explained while discussing this elastic shortening. This will definitely take place in case of pre-tension concrete member. In case of post-tension concrete member, it will not take place if the cables are stretched simultaneously. Stretched simultaneously. Okay. And yes, if cables are pulled one by one, are pulled one by one. This you need to remember, students. Okay. Sometimes he will ask you to calculate the total losses. Total losses means you should know in which type of member, which type of losses will take place. Okay. Elastic shortening will definitely take place in case of pre-tension member. In case of post-tension member, it will not take place if the cables are stretched simultaneously. and it will take place if the cables are pulled one by one. Okay. The next type of loss, second one is loss due to friction. As I said, loss due to friction, it will not take place in pre-tension member. It is takes place in post-tension member. This I already explained in the beginning only. Then third one is anchorage slip. Correct? Anchorage slip. Okay. Anchorage slip. No in case of pre-tension member. Yes in case of post-tension member. Okay. Next. Creep. Creep. It is yes for both the members. Then last one is, fifth one is shrinkage. Of course, this will be there for both the members. Yes and yes. And the last one, relaxation of stress. Relaxation of stress in steel. This will also be there in both the members. Yes and yes. Okay. So these things you need to remember to solve the problem, students. So to this theory part of this discussion on loss of stress is over. Any doubts in any discussion you can ask. Okay, students. With this, we'll start solving the problems. Okay.
Sir, last three sums from assignment is from module 2, no, sir?
I'm not getting. Loudly,
Last three
please.
sums from
Last.
from assignment.
Huh?
Last three sums are from assignment. It is from module 2, no, sir?
It's model. It is from model 2. Okay.
Okay.
So after the completion of or the after the completion of the relevant problems of model 2, you can write the answers for those questions. Okay. So anyway, today I'll be doing solving one or two problems. You will get an idea to solve the problems given in the assignment. No issues. Okay. Okay. Now we'll start solving the problems. First one, you please write the first problem. Write the first problem. Meanwhile, I will write the diagram. All of you read the problems? Also write the diagram. Okay. Go through the problem. A pre-tensioned concrete beam 200 by 300 and span of 6 meter is initially pre-stressed by a force of 400 kilonewton. Initial pre-stressing force P is given. How much it is given? 400 kilonewton. Nothing but 400 into 10 power 3 Newton. Okay. Applied at constant eccentricity of 70 mm. Okay. Written the diagram for the same. It is applied at a constant eccentricity of 70 mm by 10 tons of area 400 mm square. Okay. Eccentricity E is given. It is given as 70 mm. Okay. Then area of the cable or area of the tendon is given. Area of cable is given. How much it is given? It is given as 400 mm square. Then next models of steel and concrete is given. ES is given as 2 into 10 power 5 Newton per mm square. EC is 0.333 into 10 power 5 Newton per mm square. Okay. Then what else is given? Creep coefficient is given. Creep coefficient. Creep coefficient is given as 2. Shrinkage strain in concrete. Shrinkage strain in concrete is given as 0.0002. Relaxation of stress in steel. Relaxation in steel is given as how much? 3%. 3%. Find the percentage of loss of stress in each tendon. Okay, that is a question. Okay. See here, in almost all the problems, there will be direct calculations. Only the thing is, you need to remember the formula. Okay. Only you need to remember the formula. If you are able to remember all the formula perfectly, then you can easily solve these problems. Okay. Now we'll calculate different types of losses. What is the type of given beam given? First, you observe that type of beam given is pre-tensioned concrete beam. Okay. Pre-tensioned concrete beam. For pre-tensioned concrete beam, what are the loss that will come? I close that window. Okay. So we'll calculate one by one. First one is loss due to elastic deformation. First one, loss due to elastic deformation. Loss due to elastic deformation. Okay. Last to elastic deformation. So last to elastic deformation, how it is calculated? It is calculated as product of modular ratio and stress in concrete at the level of steel, FC, M into FC. Okay, where M is nothing but modular ratio, which is the ratio of modulus of elasticity of steel to that of modulus of elasticity of the concrete. Okay, both are given. ES is 2 into 10 power 5 and EC is given as 0.333 into 10 power 5. By this you will get modular ratio. How much will get M? You check the answer, you will get it as 6. M is equal to 6. Okay, then we got M, we need FC. What is FC? Stress in concrete at the level of steel. FC is stress in concrete at the level of steel. Okay, is FC. Okay, and formula for FC is P by A plus PE by I into E minus M by I into E. Okay, this is the formula. Now, the pre-stressing force is given. How much it is given? It is given as 400 into 10 power 3. FC is equal to pre-stressing force is given, and area, cross-sectional area, we have to calculate it. We calculate 200 by 300 is the dimensions. Therefore, cross-sectional area A is equal to 200 by 300. So 60,000 mm square. 50,000 mm square. Then I is moment of inertia. It is a rectangular section. For rectangular section, formula is BD cube by 12. Width of the beam is 200, depth is 300. So 200 into 300 cube divided by 12. Cube by 12. Please check the answer. It is 450 into 10 power 6 mm4. Okay. Moment of inertia. Then eccentricity is given in the problem. It is 70 mm. E is equal to 70 mm. Then what else is needed? We need the value of M, moment due to live load and the dead load. Okay. See here, the load on the beam is not given. Is it given? Nowhere the external load is given. Pre-stressing force is given, but the load which is acting, lay load that is acting on the beam is not given. Correct? When the load is not given, so we have to ignore this third term. Okay? When the load is not given, there won't be any moment. Okay? In the bracket you write lay load not given, and there will be some moment due to sulfate that will ignore. Okay, that will ignore. Lay load is not given and dead load is neglected. Okay, if some lay load is given, you would have calculated it moment due to lay load. Okay, and the moment due to dead load, by adding both, you would have got the value of M and you would have got the value. Okay, as the lay load is not given, we will ignore that. E is equal to 70 mm. Therefore, FC is equal to, we can substitute everything now to get the value of FC. P is 400 into 10 power 3. 400 into 10 power 3 divided by cross sectional area 60,000 plus 400 into 10 power 3 eccentricity 70 divided by I 450 into 10 power 6 into eccentricity 70. Calculate the answer. It is 11.02 Newton per mm square. Okay. Now you got the value of M, you got the value of FC. M into FC is loss due to elastic deformation. Therefore, loss is equal to, therefore, loss is equal to M into FC. M is 6 into 11.02. That is 66.13 Newton per square. 66.13 Newton per square. Very simple calculation. Only the thing is you need to remember the formula. That's it. Okay. Then loss due to, second we will calculate loss due to shrinkage. Second one, loss due to shrinkage. Loss due to shrinkage. So what is the formula for loss due to shrinkage? Yes, we have loss due to shrinkage as loss is equal to shrinkage strength multiplied by S. Correct? Loss is equal to shrinkage strain multiplied by ES. That is epsilon CS multiplied by ES. Okay. Shrinkage strain, is it given in the problem? Yes, it is given. If it is not given, in the code book it is available. Okay. 0.0003 for shrinkage pre-tension member. Okay, you need to take that. Here it is given a 0.0002, that you take. Whatever it is given, you take it. Epsilon CS is nothing but shrinkage strain in concrete. It is given as 0.0002. Therefore, loss is equal to 0.0002 into Young's modulus of steel. It is given as 2 into 10 power 5. Correct? 2 into 10 power 5. Correct. So by this we will get the loss due to shrinkage. Okay. So if you multiply, you will get 40 Newton per mm square. You get 40 Newton per mm square. Okay. Then what are the other losses that will take place in pre-tension concrete member? Here I written the table now. So it is not there. Third one, loss due to creep. Loss due to creep. Okay. Loss due to creep is calculated as, depending upon whether the coefficient of friction is given or ultimate creep strain is given. Okay. Here in the problem, what is given? Coefficient of friction is given. So you need to utilize this first formula, pi FCM. Okay. Therefore, loss due to creep law is calculated as pi FCM. Okay. And pi is given, that is creep coefficient. It is given as how much? 2 is equal to 2. Creep coefficient is given as 2. Okay. Then FC already we know, M is also known. Just substitute and get the answer. Loss is equal to pi is 2 FC. Just before we have calculated, it is 11.02 and M is 6. 11.02 into 6. Therefore, loss is equal to, if you calculate, it is 132.24 Newton per mm square. Okay. Then what type of loss? Any other type of losses that will come in pre-tension concrete beam? Loss due to relaxation of stress in steel. Loss due to relaxation. Okay. Loss due to relaxation of stress in steel. Okay. As I said, loss of pre-stress due to relaxation of stress is calculated as percentage of initial pre-stress. Okay, percentage of initial pre-stress. Let me write that formula first. Loss is calculated as percentage of initial pre-stress. Okay. So you need to calculate initial pre-stress. For calculating initial pre-stress, pre-stressing force is known. Okay. And area of tendon is also given. Correct. Area of cable is given. Pre-stressing force is given. P by A will give the initial pre-stress. Initial pre-stress is equal to initial pre-stress is equal to P by A, where area is area of cable, not area of concrete. Okay, you are calculating pre-stress in the steel. Therefore, load divided by area of steel. The load P is 400 into 10 power 3, and area of cable, how much it is given? Area of cable 400 mm square divided by 400. By this you will get initial pre-stress as 1000 Newton per mm square. Okay, and he clearly said loss due to relaxation of steel is 3%. Relaxation of steel is equal to 3%. It is given in the problem. Therefore, stress relaxation in steel, stress relaxation in steel is equal to 3% of initial pre-stress. 3% of initial pre-stress. Okay, so 3% means 3 by 100 into 1000 is the initial pre-stress. So you will get the answer as 30 Newton per mm square. Okay, so we have calculated loss due to elastic deformation, loss due to shrinkage, okay, loss due to creep, and loss due to relaxation. Okay, there are total 6 types of losses. Which are the other two losses remaining? Loss due to anchorage slip and loss due to friction. Correct? And loss due to anchorage slip and loss due to friction, it will not come in case of pre-tension concrete beam. It will come in case of post-tension concrete beam. Okay. So there will not be any loss due to friction and the anchorage slip. Okay. In case of pre-tension concrete beam, only 4 losses will come. Okay. Now we can calculate the total loss. Therefore, the total loss is equal to loss due to shrinkage, loss due to elastic deformation. It is how much? 66.13 plus loss due to shrinkage 40. 66.13 plus 40 plus loss due to creep is 132.24. 132.24. Lastly, loss due to relaxation of stress in steel 30. By this, we'll get total loss. How much we'll get is 268.37 Newton per mm square is the answer. Okay. So if you know the total loss, you can calculate the percentage loss, gross percentage loss in the pre-stress of the steel is equal to total loss divided by initial pre-stress into 100. Total loss is 268.37 divided by initial pre-stress is 1000 into 100. So by this you'll get percentage of loss We'll get it as 26.83%. 26.83%. This is the total percentage of loss in the pre-tensioned concrete member. Okay, that is 26.83. Any doubt in this calculation? Any doubt in this problem, you can ask. Okay, thank you. It's a very simple problems. The data will be given. You need to remember the formula. Okay, and you need to calculate each and every losses neatly, and adding all together will get the total loss. Then you can easily calculate percentage loss. Now we'll solve the second problem. Just write it quickly. Take 1 or 2 minutes time to write the problem. This is 1100 mm. Okay, 1100 mm. I hope you all written the problem. Just go through it. A post-tensioned pre-stressed concrete beam. Type of member is a post-tensioned concrete beam. Okay, post-tensioned pre-stressed concrete beam of span 50 meter. Okay, the length of the beam is how much? 50 meter. 50 meter is subjected to a transfer pre-stress force of 9.38 meganewton. Okay, initial pre-stressing force is given. Initial pre-stressing force, it is given. How much it is given? P naught. Let me call it as P naught. It is given as how much? Pre-stressing force of 9.38 meganewton. 9.38 meganewton. In terms of Newton, it is 9.38 mega means into 10 power 6. Okay, into 10 power 6 Newton. The transfer of force is at 28 days. Okay, age at transfer 28 days. Okay, it is given. And profile of cable is parabolic with maximum eccentricity at midspan section as 1100 mm. Here written 100 mm. Please correct it. 1100 mm. Eccentricity. It is a parabolic cable having eccentricity of 1100 mm at the center of span. Determine the loss of pre-stress and find the jacking force required. Okay, to avoid the losses. Okay, that I'll explain you how to find this jacking force. The beam is subjected to a live load of 24 kN per meter. Live load I have mentioned in the figure 24 kN per meter. And jacking is done at both ends of the beam. Jacking is done at both ends of the beam. Use the following data, all the required data, okay, to calculate different losses of pre-stress in post-tension member is given. So once again, I will not write all these data. Okay, it is clearly given in the problem. It is clearly given in the problem. Correct. Now what you do is initially you calculate initial pre-stress. Okay. To calculate percentage of loss, you should know initial pre-stress. Knowing the initial pre-stress minus total loss, you can calculate what is the percentage of loss. Okay. Now initially you calculate initial pre-stress in the cable. Initial pre-stress in cable is equal to pre-stressing force P naught divided by area of cable, not area of concrete. Remember, is equal to 9.38 into 10 power 6 divided by area of cable is given. Area of cable, how much it is given? Area of steel, it is given as 8930 mm square. 8930 mm square. If you calculate, you will get it as 1050.4 Newton per mm square. This is what initial pre-stress. In this initial pre-stress, there will be losses. Okay. Now we will calculate all those losses. Adding together, we will get the total loss. Then knowing total loss and initial pre-stress, we can calculate percentage loss. Okay. Now we will go one by one. Okay. We will go on calculating one by one. What is the first one? That we calculated in the previous problem, loss due to elastic deformation. Correct? Huh? Second one, sorry, first one, loss due to elastic deformation. Loss due to elastic deformation. See, the type of member given is post-tension beam. Okay, type of member given is post-tension beam. For post-tension beam, whether there will be loss due to elastic shortening or not. See, for Last due to elastic shortening for pre-tension beam, it will be there. For post-tension beam, with one condition, it will be there. If the number of cables are pulled simultaneously, then there will not be any loss due to elastic shortening. If the cable are pulled one by one, then there will be loss. Here, how many cables are there? Here we have only one cable. Okay. Of course, it will be stretched simultaneously only. Okay, if there are n number of cables, okay, if there are n number of cables which are stretched one by one, then there will be loss due to elastic deformation. Otherwise, there will not be any loss due to elastic deformation. Okay, in post tension member, unless and until the cables are pulled one by one. Okay, here you can write a sentence that as the cables are since since only one cable and pulled simultaneously, no loss will occur due to elastic deformation. Okay, now second one, loss due to shrinkage will calculate. Loss due to shrinkage, loss due to shrinkage. Okay, what is the formula for loss due to shrinkage? Loss due to shrinkage is the product of epsilon Cs into Es, where epsilon Cs is shrinkage coefficient. Okay, epsilon Cs is shrinkage coefficient. Okay, and it is given in the problem. No, sorry, it is. I think it is not given. Yes, it is not given. That you need to find. Okay, anyway, we'll find it. We'll find it. Okay, how to find this epsilon Cs? Epsilon Cs. We have the formula in the code book, correct? I think in page number last due to shrinkage, no? Sorry. Here only we have no the shrinkage strain. So for post tension, the type of beam here is post tension beam. So using this formula 0.0002 divided by log to the base 10 t plus 2. Using this formula, we can calculate the value of epsilon Cs, that is shrinkage strain coefficient. Okay. So from here, right, shrinkage strain is equal to epsilon Cs, which is nothing but shrinkage strain is equal to, I will copy the same formula 0.0002 divided by log base 10 t plus 2. 0.0002 divided by log to the base 10 t plus 2. This is the formula. Okay, for post tension beam. Okay, so for pre-tension beam, it is directly 0.0003. Okay, now epsilon Cs is equal to 0.0002 divided by log to the base 10. What is T? Age of concrete at transfer, it is given. Age of concrete at transfer, it is given as 28 days. Okay. So here I will write 28 plus 2, where T is equal to age of concrete at transfer 28 days. It is given in the problem. So if you calculate this answer, you will get it as 1.354 into 10 power minus 4. Shrinkage strain coefficient. Okay. Now Young's modulus of steel. It is given. How much it is given? ES. Yes, here it is given 210 gigapascal. Young's modulus of steel. ES is equal to 210 gigapascal given in the problem. So 210 giga means 10 power 9. Pascal means Newton per meter square. So in terms of Newton per mm square, it is 210 into 10 power 9. 1 meter is 10 power minus 3 millimeter square. So finally you will get 210 into 10 power 3 Newton per mm square ES. Okay. Now you can calculate loss due to shrinkage, which is the multiplication of epsilon CS and the ES. Therefore, loss is equal to epsilon CS is 1.354 into 10 power minus 4. 1.354 into 10 power minus 4 into ES is 210 into 10 power 3. By this, you'll get loss due to shrinkage. If you calculate, you'll get the answer as 28.43 Newton per mm square. Okay. Now till now we have calculated two losses: loss due to elastic deformation, loss due to shrinkage. Still we need to calculate four more losses: loss due to creep, okay, loss due to relaxation, loss due to anchorage slip, loss due to friction is there, okay. Still 3 to 4 different losses we have to calculate to get the total loss, okay. So time up. So we'll stop the class for today and we'll continue this problem in the next class. Okay, students. Thank you.